Good morning, girls. Previous class we done rate of a reaction or velocity of a reaction, right? Today is the factors affecting rate of a reaction. What are the factors mainly affect the rate of a reaction? First one is concentration or pressure of the reactants. Concentration means in terms of solutions. Pressure means if the reactants are which one gas molecules. Okay, so first factor is concentration or pressure of the reactants. Second one is temperature of the reaction. Third one is surface area of the reactant. And the fourth one is nature of the reactant. And next one is which one? The fifth one is radiation, exposure to radiation. So what are the factors? First one is concentration or pressure of the reactant, then temperature of the reaction, surface area of the reactant, nature of the reactant and exposure to radiation. So first factor we are taking and explaining the first factor, concentration of the reactant. First factor is which one? Concentration of reactant. Okay. So we know if the concentration increase remains according to the Le-Chatelier principle, what is happening? The rate of the reaction increases. Okay. So rate of the reaction is proportional to the molar concentration of the reactants raised to some powers they are experimentally determined. I don't know, last year equilibrium chapter, rate R is proportional to concentration of A raised to some power we were writing. Okay, so what is rate of a reaction is proportional to the molar concentration of the reactants raised to some powers, or raised to some exponents. That exponents are experimentally determined. Okay, so the expression which gives the relationship between rate of the reaction and the concentration of the reactants is known as rate law or rate expression. So what is rate law or rate expression? The expression that gives the relationship between concentration of the reactant and which one? The rate of a reaction is known as rate law or rate expression. Rate law or rate expression. Okay. So the relation, there is an expression or equation gives the relationship between rate of a reaction and the concentration of reactants is known as rate law or rate expression or rate equation. Okay. So how we can, the rate law or rate expression, how we can write for a particular reaction. Okay. So consider a reaction AA, general reaction AA plus BB gives CC plus DD. This equation is commonly using for general type of equation in this chapter. Okay. So rate, we know rate is proportional to which one according to the rate law? Rate is proportional to the molar concentration of the reactants, which is the raised to some powers. Okay, and these powers are experimentally determined. So how we can write? Rate is proportional to concentration of A, the first reactant, raised to some exponent X into concentration of B raised to some exponent Y. Okay, so this X and Y is the exponents and these are not equal to A and B. These are not equal to A and B. Sometimes it may equal to, exponents may be equal to the reactant. We know this is stoichiometric coefficient. Okay, so sometimes these x and y exponents may be equal to this one. Which one? The stoichiometric coefficient. Sometimes it may not be equal. Okay, so here A and B are, we know it is stoichiometric coefficient, but x and y are some exponents. They are determined experimentally. Okay, so rate is proportional to concentration of A raised to X into concentration of B raised to Y. So rate equal to, we have to remove the proportionality sign. Rate equal to K into concentration of A raised to X into concentration of B raised to Y. Okay, where K is known as which one? Rate constant. What is K? K equal to rate constant. K equal to rate constant or a specific rate of a reaction. So K equal to rate constant or specific rate of a reaction. Okay. We know rate. Last class we wrote rate, instantaneous rate, that is minus dr divided by dt equal to, this is according to which one? Concentration of the reactant. So minus dr by dt equal to K into A raised to X into B raised to Y. Okay. So rate equal to, that is, this is known as which one? The experimentally determined rate expression or differential form of rate expression. Why it is known as the differential form of rate equation? Because we are using the differential d. Okay. So d minus dr by dt equal to K into concentration of A raised to X into B raised to Y. Okay. Where K equal to rate constant or specific rate of a reaction. Okay. So in this equation, if concentration of A equal to 1 unity and the concentration of B equal to 1, then how we can write the rate of a reaction? That is minus dr by dt equal to what we will get? Okay, K, because this A equal to concentration of A equal to 1 and concentration of B equal to 1. We are taking the concentration of the reactants A and B as unity. Then the dr by dt will equal to which one? The rate constant K. So how we can define the rate constant K? Rate constant K equal to the rate of the reaction when the concentration of the reactants are taken as unity. Clear? Rate constant K equal to the rate of a reaction when the concentration of the reactants are taken as unity. Clear? So that is first what we have to write. Rate is proportional to what is a reactant raised to some power raised to the power. Then we have to remove the proportionality sign. Then we will get this one. Okay. So that is what writing the rate expression or rate law for any type of general type of equation. So how we can identify the stoichiometric coefficients may be equal to the which one? Stoichiometric coefficients may be equal to the exponents or not equal to the exponents. Okay, so we have to apply the this one, which one? Calculation, the differential rate expression to a particular examples, and I will explain how the stoichiometric coefficients are equal or not equal to, how we can identify that it is equal or not equal to the exponents. Okay, so consider the equation 2NO plus O2 gives 2NO2. Okay, so here how we can write the experimentally determined the rate expression is minus dr divided by dt equal to K into NO square into O2. Okay, so they wrote the experimentally determined rate expression. Here you can see this is the exponent here 2 and here it is 1. Okay, and this is same as which one? Our coefficient, stoichiometric coefficient 2 and here 1. Okay, in this case both are equal. How we can identify this is on experimentation they doubled. Okay, they doubled the concentration of NO, keeping oxygen constant. Okay, so they double the concentration of NO, keeping oxygen constant. Then what is happened is the reaction rate of the reaction is increased by 4 times. How many times? It is increased by 4 times. Okay, so for getting 4, what is there? It is doubled. So the exponent should be 2. Then only 2 square we will get 4. Clear? Okay. So on keeping, they increase the concentration. They double the concentration of NO, keeping oxygen constant. Concentration of oxygen constant. Then the rate of reaction is increased by 4 times. Okay. To increase the rate of reaction 4 times means what is that? Here it was 1, so it is doubled 2. So the exponent will be square. Then only we will get 2 square and the rate of the reaction is increased 4 times. Clear? Next what they done? So the exponent is clear here. We got 2. Okay. Next what they done is they double the concentration of oxygen, keeping the concentration of NO constant. They doubled the concentration of oxygen. Okay, keeping the concentration of NO constant. So the reaction rate is increased 2 times. Reaction rate is increased 2 times. Okay, so we know it was 1. Okay, it is doubled, so it is become which one? 2. Then it is the reaction rate is increased 2 times. So 2 raised to 1 only we will get 2 times, right? Okay, if the exponent is 1, then only after doubling 2, 1 it is doubled, so 2, then 2 raised to 1 only we will get which one? 2 times. Okay, here it is 2 raised to 2, then only the reaction will be increased 4 times. Here the exponent will be 1, then only the reaction rate will be increased 2 times. Okay, so here what is happening? The exponents and which one? The stoichiometric coefficients are equal. Then here if you are considering this reaction, chloroform CHCl3 plus Cl2 gives CCl4 plus HCl. Okay, so in this reaction, on experimentation, they double the concentration of CHCl3, keeping the concentration of Cl2 constant. Then the rate of reaction is increased by 2 times only. It is increased by 2 times only. Okay, so it was 1. First chlorine 1, chloroform 1. Okay, then it is doubled 2. Okay, so the rate of the reaction is increased. Rate of the reaction is, rate is become how much it is? Rate is become 2 times. 2 times means what is? The exponent will be 1. Right, the exponent will be 1. Then only this reaction become 2 times. Clear? Okay, then next what they done is they increase, double the concentration of chlorine, keeping this one constant, chloroform. They double the concentration of chlorine, keeping the concentration of chloroform constant. Then the reaction is increased by how many times? Root 2 times. Only root 2 times the reaction is increased. Then what will be the exponent? It was first chlorine concentration 1. It is they double 2. Okay. Then the rate is increased by root 2 times. So to increasing the rate root 2 times, what will be the coefficient? 1 by 2. Then only 2 raised to 1 by 2 we will get which one? Root 2. Clear? Okay. So from this experiment, it is clear that what is the coefficient of chloroform? Chloroform is CHCl3 equal to 1, and what is the coefficient? Not coefficient, what is the exponent of chloroform? It is 1, and what is the exponent for chlorine? It is 1 by 2. Clear? Okay. So first what they done? They double the concentration of this one. Then the reaction rate is increased 2 times. To increase the reaction rate 2 times, the exponent will be 1. Okay. Then they double the concentration of chlorine, keeping this one constant. Then the reaction rate is increased root 2 times. To increase root 2 times, the coefficient will be what? 1 by 2. Okay. So chloroform CHCl3 raised to 1. Cl2 raised to 1 by 2. So how we can write the differential rate expression for this reaction? Chloroform plus Cl2 gives carbon tetrachloride plus HCl. How we can write? Minus dr by dt equal to, we already know what is that? Concentration of CHCl3 raised to 1. 1 is not compulsory to write. Then what is that? Concentration of Cl2 raised to 1 by 2. Okay. So what they are doing on experiment, one they will keep constant and they will increase the other. So from that they are identifying how much increase in the rate of the reaction. From that we can find out the exponents of a reaction. So here how we can write the rate of a reaction for this one? Minus dr by dt equal to C concentration of CHCl3 raised to 1 into concentration of Cl2 raised to half. Okay. So that is about which one? The experimentally determined rate expression for different reactions. Clear? Next is order of a reaction. Very important. Order of a reaction. Okay. What is an order of a reaction? Order of a reaction. Very important. They will ask what is the order of a reaction. Okay. We know what is the rate expression, differential rate expression, minus dr by dt. okay, equal to K into concentration of A raised to X into concentration of B raised to Y, right? Okay. So what is order means N. We can use the letter N equal to X plus Y. So what is order? Order equal to N equal to X plus Y. So what is the order of a reaction? It is a sum of the powers of reacting species. Sum of the powers of the reacting species in each reacting term in which one rate law expression. Okay. So what is the order? It is a sum X plus Y. It is a sum of powers of concentration terms in each reacting terms, each reactants in a rate law expression. It is a sum of powers. Nothing is simply we can say it is sum of the powers of reacting species. Okay, in a which one? In a expression. Which expression? Differential rate expression. Okay, so here N equal to what? X plus Y. It is a sum of the exponents or sum of the what? Powers of reactant species. Reacting species in which one? In a differential rate expression or rate equation. Okay, and this one of the characteristics of order is order may be from 0, 1, 2, 3 and 4 is maximum. More than 3 is rare case. Okay. Then order may be 0. It can have 0 value. It can have fractional values that 1 by 2, 3 by 2, etc. And it can have negative values. It can have negative values. And order of a reaction is mainly depending upon which one? The mechanism of a reaction and also the rate of a reaction. So order means what is the sum of the powers of the reacting species in a rate law expression. So here X plus Y gives the order of a reaction. Okay. So next is unit of a rate constant. Very important. They will ask, write the unit of a rate constant. Okay. So for a general type of reaction, AA plus BB gives CC plus DB. This is a common reaction in kinetics, right? Okay. So how we can write the rate of a reaction? Minus dR by dt equal to K into concentration of A raised to X into concentration of B raised to Y. Here we know X and Y are which one? The exponents. Okay. And we know this one minus dR by dt equal to what? Rate. It is equal to rate. Okay, and X plus Y equal to N. N is known as which one? The order of a reaction. We know that. Okay, so rate equal to, how we will get? K into concentration of A raised to X into concentration of B raised to Y. Clear? So how we can take the K, rate constant? Okay, K equal to rate divided by concentration of A raised to X into concentration of B raised to Y. Okay. So last class I already told you rate equal to, what is the unit? How we can write the unit of rate? Okay. So rate equal to, what is that? Concentration divided by time. Rate equal to concentration divided by time. And this part. Okay. So how I will write is, once again I will write rate equal to, so rate equal to concentration divided by time. So K equal to concentration, rate I am writing, concentration divided by time into, this is what separately I am writing, 1 by A raised to X into B raised to Y. See, this is which one? Concentration of A and concentration of B. So generally I am taking that as concentration. Concentration raised to X plus Y. I told you what? N. Concentration N. Okay. So here derivation is not at all required. Only you have to know what is the unit of, what is the rate constant, unit of rate constant for a zero order reaction, first order reaction and second order reaction. Okay. So generally rate constant K equal to concentration divided by time. That is for which one? Rate, unit of rate concentration divided by time into 1 by A raised to x into B raised to y. Generally, I'm writing this is the concentration term A and B, and x plus y equal to what? Order of a reaction. So, N. Okay. So, how we will write? That's equal to concentration, how we are expressing moles per liter divided by time, how we are writing second, into 1 by concentration, what is that? Moles per liter raised to n. N may be which one? 0. If it is a 0 order reaction, N may be 0. If it is a first order reaction, N may be 1. If it is a second order reaction, N may be 2. Okay. So generally this is the equation. So for N equal to 0, that means for a 0 order reaction. For a 0 order reaction, what is the unit of rate constant K? Okay. So K equal to moles per, this part no change, no, into 1 by moles per, concentration means moles per liter, no, right, okay, moles per liter raised to 0, okay. So, we know something raised to 0 equal to 1, so this part will be equal to what? 1. So, what we will get? Moles per liter second. Second will go to and moles per liter per moles per liter per second. Okay. So, moles per liter per second. That is the unit of which one? 0 order reaction. Then, for a first order reaction, how we can write is that is equal to moles per liter per second into 1 by moles per liter. What is that? 1. So this is 1. Okay, here 1 means moles per liter, and this one will cancel and we will get second inverse. That is for which reaction? First order reaction. Okay. Then for a second order reaction, how it will be? This part, this N will be 2. Okay. So here 1 and this 1 is 2 is there, no? 1 will get cancelled and we will get here. This is 1 will be there, no? So second also, this is moles per liter is there. 2 was there, 1 get cancelled. So here moles per liter inverse is there. Okay. Second is there. So second inverse. So mole, not that. Moles per liter is there and second is there. This will go up. So how we will write? Equal to mole inverse liter. Inverse will go to top, liter, then second inverse. Okay. So that is the unit of which one? Second order. Getting what I'm telling. Here this is there. Second order means N equal to 2. So here moles per liter 2 is there, no? So 1, this one and 1 will cancel. Then 1 moles per liter is there. That moles per liter will go up. Then mole inverse liter, then second inverse. That is for which one? Second order reaction. So for generally, how we can write the order, how we can calculate the unit of a reaction. Okay. So how we can calculate is, generally the rate constant K is given by mole 1 minus N liter N minus 1 second inverse. Okay. For example, if order N equal to 0, how we will calculate? That's equal to mole 1 minus N equal to 1 minus 0. 1 minus 0 liter. What is that? 0 minus 1 second inverse. Right. So how it is? Mole raised to mole. 1 minus 0 equal to 1 mole liter minus 1 second inverse. That is which one? For a 0 order reaction. When N equal to 1. So how we will write? Applying this mole 1 minus 1 liter 1 minus 1 and second inverse. So what is that? 1 minus mole raised to 0 equal to, okay, then this is also 0 and we will get second minus 1. So generally mole raised to 1 minus n. Okay. Liter raised to n minus 1, s raised to minus 1. If you know this one, you can write the unit for rate constant for any order reaction. Okay. So they will give some problem like 2.8. The rate constant of a reaction is 2.8 second inverse. Then what is the order of reaction? So how we can write the order of the reaction? Unit is second inverse. So what is the order of the reaction? Second inverse means we know the order of the reaction equal to 1. So n equal to 1. Clear? That is about the order of reaction. So that is about today's topic, girls. Thank you. Thank you so much.